Hello. Hope you're going well. So, starting up the White Chipmunks after party. See how we go. Slow, slow, slow. Ah. It's getting there. It's getting there. Interesting. But yeah, looks like we're going. Hope you're all going well. Now, if you have any preference to what book we might want to cover, anyone's interested in listening to me rattle off the history of Australian seashore life, or numerous other topics about aquarium keeping and plant keeping, we'll see. Glasses, woohoo! That helps. The seashore is one of the most interesting regions of the earth. There you'll find plants which resemble animals, animals which look like plants. In no other part of the world is there such variety of colour, shape, and form of living things. Yet the man in the street remains very ill-informed of the nature of these creatures and their relationship to the animal life of the land. Fishermen who have spent years at the seashore still wonder whether the conjovoy is plant or animal, and regard rock barnacles as relatives of the oysters. Most Australians live within a few miles of the coast, and most of us regard the seashore as our main place of recreation. Every summer, tens of thousands of children clamber over rocks, explore the pools and crevices, come back with treasure, shells, crabs, skeletons, seaweed, and hosts of other mysterious objects. Nobody in the family knows what they are, and they're tossed away. This little book has been written to help people appreciate the wonderful variety of life at the seashore, and to be able to recognize some of the most important groups of animals found there. It includes a simplified account of the general body structures of the animals and of the way in which they feed, obtain oxygen, and reproduce their kind. I've deliberately given more space to the less well-known groups of animals and treated such groups as crabs and shellfish rather briefly. I have two suggestions to the keen nature student. First, always take a hand lens and a small dish for closer examination of specimens. Second, try to set up a saltwater aquarium at home for further study of the living specimens. Many of the photographs in this book were taken by Mr. Justice F. G. Myers, for whose assistance I am extremely grateful. That's written by John Child, the author of this book. Australian Seashore Life by John Child. There's a picture of the seashore. There's a speckled anemone. These are black and white photos. The book's from 1962. So it's all black and most of it's black and white, I do believe. I think maybe all of it. No, there is colour, sort of, kind of. I suppose you call it colour. Some colour. So life in the sea. Before we can begin to study the plants and animals which live in the sea, we must know some of the basic facts about the sea itself, its movements and the substances of which it is made. Because in this book we shall be dealing with animals of the seashore. We need to understand the movement of the tides. Also, we must know a little about the food resources of the sea, not about the food fishes which man eats, but about the different types of food which the smaller animals of the seashore take into their bodies, and the various ways in which they do this. Tides. Everyone knows that the tide comes in and goes out, or rises and falls, roughly twice in every 24 hours. The reason is fairly simple. All objects pull on other objects with a pull called the force of gravity. Gravity. Let's carry on. Not sure if Vinny's going to be hearing that. If the objects are small or far apart, the pull is too weak to make them move. But if one of the objects is large or fairly close to the other, it can make the latter move towards it. The sun is much larger than the Earth, but it is about 93 million miles away. The moon is much smaller than the Earth, but it is only 500,000 miles away. The pull of gravity from the sun and the moon is not strong enough to shift the Earth from its regular path around the sun, but it is strong enough to move the water masses on the Earth a few feet towards the other bodies. Because it is so much closer than the sun, the moon's pull is actually the more powerful. As the moon moves around the Earth, it comes into a position where its pull tends to cancel the pull of the sun. At this time, the movement of the tides will be small. They are called Neap Tides. At certain times, the pull of the sun isn't exactly the same of the tides at its greatest. At these times, the movement of the tides is greatest. Not sure if I skipped a sentence there, but carry on. These are called spring tides. They have nothing to do with the season spring. Spring tides occur at the new moon and full moon, and neap tides at the first quarter and last quarter. Because the moon travels once around the Earth in 28 days, each neap tide is separated by the next spring tide by 7 days, and there are 2 spring and 2 neap tides each month. Zones of the seashore. The movement of the tides is vitally important. Sorry, skipped a picture. Oh, can we see it? Can we see it? Can we see it? There's a photo of the moon's pull on the Earth and that sort of jazz. Nice. So zones of the seashore. The movement of the tides is vitally important to all the animals which live on the seashore. It means that the part of the day they are submerged between the sea, and for part they are exposed to the weather, to wind, to rain, and sunshine. This means also that there are fairly sudden and sometimes extreme changes in temperature, moisture, food supply, and other conditions. If they are to survive, animals and plants must be able to withstand the 2 very different sets of conditions. The study of the ways in which they do this is one of the most interesting branches of biology. We find that some animals can withstand only a short exposure to the air and the sun. These animals live down the shore towards the low tide level. Others can live for long periods out of the water. These are found towards the high tide level. Still others are intermediate. A few can live right out of the water above high tide level as long as they are occasionally splashed with spray. Some very adaptable animals and plants may be found at almost every level on the seashore. This tendency of seashore creatures to inhabit a certain region is very regular, and the keen student should be able to use this zoning, as it is called, in various ways. In fact, the different zones on any coastline are often called after the most prominent plant or animal inhabitants. Food and energy. All living creatures require food for two purposes. Firstly, they use the chemical substances in food to build new cells in the body, either to replace worn-out cells or to enable them to grow larger. Secondly, they need food for energy so that they can move about. A living creature cannot move without energy, any more than a motor car can run without petrol. And just as the motor obtains its energy by burning the petrol, that is, combining it with oxygen from the air, so most animals, obtain energy by burning their food, combining it with oxygen. And again, just as the burning of petrol produces poisonous waste gases, which are removed through the exhaust, so the burning of food produces waste gases which have to be removed. Man and other high animals breathe out the waste gas, carbon dioxide, from their lungs through the nose and mouth. This very brief account must serve to introduce us to several important questions which we must always be asking ourselves when studying living animals. What is its food? Does it eat plants or animals, or both? Does it eat them alive or dead? How does it obtain its food? Is it swift-moving and able to catch its food on the run, or is it absolutely fixed so that it has to wait for its food to come along? From sort of grasping organs does it use, or what sort of grasping organs does it use? Sharp hairs or claws or pincers or suckers? Does it swallow the food whole or grind it into small pieces? How does it obtain oxygen? How does it get rid of carbon dioxide? Some of these questions we shall attempt to answer in the later sections of this book. We must now consider briefly the very important question: where does the food come from? Why doesn't all food in the world on land and sea become eaten up? The answer is simple. All food comes ultimately from plants. And all over the earth, on land and sea, plants are making more food to replace that which is consumed by the animals. The commonest elements in most foods are carbon, hydrogen, and oxygen. The air contains a gas called carbon dioxide, composed of carbon and oxygen. Water is composed of hydrogen and oxygen. By combining these two common substances, plants can make starches and sugars, carbohydrates, the basic food stuffs. The process is highly complicated. Easy for you to say. The process is highly complicated, and the cleverest scientists cannot copy it. It is called photosynthesis. Photo means light, synthesis means combining. The energy for the process comes from sunlight. Have you ever wondered why nearly all leaves are green? The answer is that the leaves are the parts of the plant in which food manufacture goes on, and that they all contain a green chemical, chlorophyll, which is essential to the process. Thus, we can state simply this very important chemical process on which all life depends. Carbon dioxide plus water, sunlight energy over chlorophyll present gives you starch, sugar. So, whoa. Can we see that? Can we see that one? Don't know. Don't know. We're trying. Maybe. That's all right, isn't it? Maybe. Might be able to see that. There we go. On land, the plants was to produce starch, other grasses, herbs, shrubs, and trees with which we are familiar. Sometimes we eat the leaves directly, such as cabbage and lettuce, but most often we eat the other parts of the plant in which the food has been stored, such as the seeds of wheat, the roots of carrot, the fruit of apple, etc. Around the edge of the seas of the world is a narrow strip where the plants, which we call seaweeds, are large and green and look something like land masses. Unfortunately, not many of them are edible to man. They are, however, eaten by small fish and other sea animals. It is important to realise that there are no seaweeds out from the shore in the deep water. G'day, Aquamate. How we going, mate? Doing a bit of reading? just a bit of light reading. Australian Seashore Life by John Childs. It is important to realise that there are no seaweeds out from the shore in the deep water. They could not live on the seabed there, for there is little light at depths beyond about 200 feet, and sunlight is essential to plant life. But you may ask, if there are no plants over the vast expanse of the ocean, what provides the food for the teeming animal life, the fishes, squids, whales, sharks, porpoises, and other animals of the deep? The answer is that out in the deep ocean, there are plants, but they're not like the ones we call seaweeds. They are tiny microscopic one-celled plants called diatoms. They exist in the countless millions in the surface water of the oceans. They produce food by the process of photosynthesis, just as the land plants do. The tiny plants are then eaten by the tiny animals. These tiny animals are eaten by larger ones, and so the process goes on. Feeding habits. Having sketched the way in which food is produced, we must now mention briefly the way in which seashore animals take the food into their bodies. 1. Some feed on the larger seaweeds. They are called plant eaters, herbivores. 2. Some feed on other living animals. These are called predators. 3. Some feed on dead and decaying remains. These are scavengers. 4. Some feed on small particles of plant material which they sift from the sand. These are detritus eaters. 5. Some filter microscopic plants and animals from the seawater and are called filter feeders. And 6. Some move about slowly, scraping very tiny plants from the rocks. These are sometimes called browsers. There is still much to be learned about the feeding habits of even quite common seashore animals. By careful observation, you may be able to add to our knowledge in this field. Scientific classification and names. The first major classification of living things is into plants and animals. You may think that this is very obvious. Anyone can tell a pine tree from a hippopotamus. However, it would be unwise to think the beginner can always tell an animal from a plant in a rock pool. There are fine fern-like creatures which are in fact animals, and flower-like creatures which are animals, and living things with limey skeletons which are plants. Apart from one brief chapter on some common sea plants, this book is concerned mainly with animals. Each chapter deals with one major group of animals. The scientific name for such a group is a phylum, pronounced phylum. Each phylum is then divided into a number of classes. Each class is further divided into orders, and the order into families. Each family contains still smaller groups, each of which are called a genus. Finally, the genus contains several species. Examples of species are blue swimmer crab, rock oyster, black periwinkle, king prawn, heliotrope sponge. Unfortunately, there are often different popular names in different places for the same species. It is necessary, therefore, to use the scientific name where possible if we wish to avoid confusion. The scientific name of a species consists of two words. First, the name of the genus to which the animal belongs. Second, the species name. Thus, the scientific name of the blue swimmer is Portinus pelagicus. The scientific name of the rock oyster is Crassostrea commercialis. Well, there we go. Didn't know that one. The detailed study of the classification of plants and animals is very difficult, and even the experts sometimes disagree. Most biologists today, however, agree that there are about 30 main phyla of animals. We shall deal with only 10 of them, the ones most commonly met with on the rocky seashore. There we go. So there's chapter 1. Chapter 1, done and dusted, people. That wasn't that painful, was it? Hopefully not. I can continue if you wish. Chapter 2 is seaweeds. Seaweeds. It's going to be fascinating. You know it is. You know it's just going to blow your mind. Finding all about seaweeds. Because seaweeds are among the most beautiful of plants. But to see them at their best, you must visit them at home. The best way to do this is to wear a mask and snorkel. Even without venturing into the open sea, a new world will be revealed in any rock pool. Once you penetrate beyond the dulling and distorting surface of the water. The colours which range through greens, yellows, brown, red, purple are not in the flowers, for seaweeds have no flowers. Strictly speaking, seaweeds have no leaves either, nor roots, nor stems. In the land plants, the stems are usually quite different in colour, hardness, and structure from the leaves, but you will notice that in seaweeds, the stem is the same colour and texture as the leaf, but is thickened instead of flattened. This leafy part of the plant should be called the frond. Some seaweeds, pulled from the rock or washed up on the shore, appear to have a tangled mass of branching roots. True roots of land plants are used to absorb food and water from the soil, as well as to anchor the plant to the earth. The root of a seaweed serves only to anchor it. It is therefore called the holdfast. Seaweeds are classed together in a large division of the plant kingdom, called the algae. Hundreds of algae are extremely small, indeed microscopic plants. Let's just revisit that. Seaweeds are classed together in a large division of the plant kingdom, called the algae. So seaweeds are algae. How spun out's that? Hundreds of algae are extremely small, indeed microscopic plants, consisting of only a single cell, diatoms, are one large and important group of the algae. At the other extreme are the huge bull kelps, which live in the colder oceans, whose fronds may be over 100 feet long, forming great submarine forests. See colour plates 1 and 2. There's color plate number 1. Can we see it? Can we see it? Can we see it? And we better go to plate number 2. Unless that is plate 2. No, that's plate 2. Plate 2. Can we see it? No. There we are. That's just like a string algae type thing there. And that's some of the algae. Ooh, pretty freaky stuff. So, seaweeds are divided into 3 groups according to the colour of their fronds: green seaweeds, brown seaweeds, and red seaweeds. The colour of the seaweed is related to the depth at which it usually lives in the water. As sunlight passes down through the water, some colours are absorbed more quickly than others. Those seaweeds which live near the high tide line are naturally the same colour as the land plants green. But those which live from about mid-tide level down to low tide level have to use different light because some light rays are absorbed in the surface water and therefore have a different pigment, which gives them their olive brown colour. Those which live in deeper water still have to use a different kind of light and contain a red pigment. Of course, always in the world of nature, there are many exceptions to this general rule, but it's a good basis on which to begin to sort out the seaweeds. Cheers, Ackle, mate. Yeah, gotta love the fender. Good value. So the green seaweeds, baitweed or greenweed. As you climb down from the cliff to the rock platform, you may come across a patch of green, mossy growth. It is usually found near high tide level in a damp region where water soaks out from the cliff. Examined more closely, it is seen to consist of fine green threads, which sometimes appear tubular, the centre part being filled with gas. That is the enteromorpha, which I think we can see in the middle picture of these 3. Let me try and get that there with some sort of about. Turn that off. No, that doesn't help. Well, maybe it does. Does that help? No, that doesn't help. No, well. Like that. Maybe. On the angle. Ooh, dodgy. But apparently that's enteromorpha, baitweed or greenweed. Then there's ulva lactuca, sea lettuce. On the lower levels of rock platforms, there are usually patches of a small green seaweed with broad, flat, crinkled fronds, not unlike the leaves of a young lettuce. It is rather adaptable plant and flourishes in estuaries as well as on the open coast. Furthermore, it will be found at low tide level among the conjovoy and in shallow rock pools, quite high on the shore. And then green sea velvet. There are several species of sea velvet, which is Codium species. They're not difficult to recognize because of the way in which the finely branching fronds are packed tightly together Most of them are rich, dark, bottle green colour, and some are almost black. The general form differs from one species to another. One species, Codium fragile, has rounded branching fronds about a quarter-inch thick, perhaps 1 foot long. Another species grows into a velvety ball mass. Another forms a carpet on the rocks. The brown seaweeds show a great variety of sizes and shapes, from fine hair-like growths in rock pools to the giant bull kelps of cold oceans. Despite this variation in body, they are all alike in the way in which they reproduce. Necklace seaweed, or Neptune's necklace. Hormosira banksii. This seaweed is quite unmistakable. There it is at the top. You can see the necklace-like strands. So I believe those balls will be filled with gas, but we'll find out. Necklace seaweed, or Neptune's necklace. This seaweed is quite unmistakable. Its body consists of rows of olive green beads, about half an inch in diameter, joined by short stalks. Each bead has a rather rough surface due to numerous pores. Each pore leads into a little flask-shaped chamber where the reproductive cells are produced. Bubbleweed. This brown seaweed is almost unmistakable, for its body is a pale brown crinked bubble. It is found in sheltered rock pools about mid-tide level and also in estuaries where it often attaches itself to the strapweed. Cool. Banded fanweed. In this little brown seaweed is common in rock pools towards the lower tide levels. The body consists of curved fan-shaped fronds up to 2 inches in diameter, marked with concentric bands of light and dark shades. Pocockella. Here we go. Ooh. The floor of a shallow rock pool may be covered with densely packed clumps of a light brown seaweed with rounded, irregular frond, about 2 inches in diameter. The fronds are not fan-shaped or banded like those of the fanweed. Sausage weed. The body of this plant resembles a clump of small, wrinkled sausages, about 3 inches long. Common in summer along the southeast coast of Australia, it sometimes forms a distinctive band on the rocks about the mid-tide level. The swollen fronds are filled with slimy material. The outside is covered with small pores, which lead into the reproductive chambers. Then there's doubling weed. This weed gets its name from the habit of the fronds by dividing regularly into two. The fronds are flat, about ½ inch wide, and up to 8 inches long. It is found towards the low tide level. Crinkled doubling weed. This looks rather like the preceding species with its flat brown dividing fronds, but it can be identified by the peculiar crinkles along the fronds. It also is found in deeper rock pools towards low tide level. Northern kelp, Eclonia radiata, a small relative of the giant kelp of colder southern waters. This seaweed is found just below the lowest tide level. Each full-grown frond has a tough, leathery, strap-like central portion with a number of small straps on each edge at right angles to the central part. The surface of the fronds is covered with soft, spiny projections, and the edges are often crinkled. There is a short, rounded stalk, a stipe, and many branched holdfast, which, as we know, are the roots of seaweed. The holdfasts of Eclonia, washed up after storms, are good places to search for small crabs, sea spiders, starfish, and other animals. Bladderweed or popweed. The name of this genus comes from the spindle-shaped bladders, which help to keep the fronds upright in the water and therefore exposed to sunlight. The fronds are strap-like, with many branches. The colour is a light olive with a golden tint, which is very beautiful when viewed under water on a bright day. It is one of the great group of seaweeds known in England as the racks, which are used there as indicators of the different shore zones. And then bull kelp, Sarcophycus potatorum. Biologists of the southern shores need no introduction to this plant, whose broad, dark green, rubbery fronds wave majestically in the swirling waters below the low tide level. It may grow up to 20 feet long, with fronds 1 foot wide. The holdfast is a bell-shaped expanded disc. Reed seaweeds, the Rhodophycae. Most red seaweeds live in the deeper water below low tide level and are therefore not within the field of this book. There are, however, a number which grow commonly in the intertidal zone, often forming thick, coarse mats or clumps. This coarseness is caused by the coating of limestone which surrounds the delicate fronds. When alive, these seaweeds have a purplish or pinkish hue, but when they die and the living part decomposes, the limy part remains as a white, fern-like branching skeleton resembling some species of branching coral. This family of the red seaweeds is in fact called the corallines. So coralline algae. Identification of the different species really requires a microscope, but some of the more common ones can be identified by the form of the limy skeleton and the habit of growth. Red seaweeds with limy jointed skeleton. That's it, Canistio. Corallina. Lena. Species of Corallina are usually small, about an inch in height, with very fine fronds and joints about 1/40th of an inch apart. The fronds divide into 3 or more branches. Amphiroa. Members of this genus are larger than Corallina, perhaps 3 inches tall, and the sections of the fronds are about 1/4 inch long and clearly flattened. Amphiphora anceps is the common species in rock pools in New South Wales, but on the south coast of Australia, Amphiphora stallifera, starry Amphiroa, is the common one. Arthrocardium, cardium, heart, anthro, joint. So there we go. Canistio, there we are, man. We've just now got a joint seaweed. So cool. We can smoke that one. In this species, the segments of the central part of the frond are heart-shaped, broad and flattened, and the branchlets are so arranged that there is practically no open space in the frond. Red seaweeds with limy skeleton, not jointed. No joints. These are more difficult to identify. There are a few found in the intertidal zone, which the amateur may recognise. Sometimes the rocks or the shells of slow-moving mollusks may be encrusted with a thin layer of pink stony material and look as if they have been coated with a thick paint or coloured cake icing. This stony crust contains the soft fine fronds of a small coralline seaweed known either of Malabesia or Lithothamnion. In another genus of closely related red seaweeds is a plant whose broad, rounded fronds grow almost upon the rock, like a lichen. The fronds may be hairy underneath, although they contain lime. They have a leathery rather than a bony texture. The plant, oh, here's a good one, Pasonellia. The plant is Pasonellia. Strangely enough, perhaps the first red seaweed which you might find would be a slippery patch of fine, brown, mossy growth about 2 inches long near the high water level. This plant is Bangia. It is a true red seaweed, despite its colour and its habitat. In almost any small rock pool, you will find short thread-like fronds of small red seaweeds. These are probably species of Polysyphonia, of which more than 200 species are known, but it would require an expert to distinguish one from the other. Terracladia. This species is fairly distinctive, for it has larger fronds than other red seaweeds in the shore zone. The fronds are open and fern-like, with a narrow blade-like central part with branches and branchlets, very similar to a frond or bracken. The red wormweed, Nemoleon helminthioids. As the name implies, the fronds of this plant are rather like long, thin earthworms, brownish red in colour. Several fronds grow from the common base. Blue glowweed. One of the most fascinating sights of a shore rock pool is a sudden flash of brilliant blue-green light as a patch of dull brownish seaweed moves in the current. This comes from a small, otherwise insignificant red seaweed with flattened, ragged brown fronds, about an inch long. Unfortunately, when it is removed from the water, the beautiful colours fade away as if by magic. The flowering plants of the sea. Strangely enough, only 2 of the thousands of known species of flowering plants live immersed in the sea, and both are found in many parts of the world besides Australia. Eelgrass. This plant is found in estuaries, growing in extensive beds, zostera, which may be completely uncovered at very low tide. It has a creeping stem rhizome, which runs beneath the surface of the silty mud. From this, the green grass-like leaves, about 6 inches long and quarter-inch wide, grow upward in regular intervals. The plant has true flowers, but they are very inconspicuous, and I must confess that I have never found them. Eelgrass beds are a favourite haunt of many sea creatures which shelter beneath the dense thicket of dead and living leaves. Finally, strap leaves. The leaves of this plant are much larger than those of eelgrass. They may be several feet long and about half an inch wide. It grows in deeper water than eelgrass, and is therefore seldom completely exposed to the air. The flowers, which are a bright greenish yellow, begin to appear in spring and are quite conspicuous. And there's black and white shot Caroline seaweeds growing on and amongst Kunjavoi. Here we go. That's the end of chapter 2. That might do us. Might do us for today, eh? 2 chapters. We're nailing it. It's damn hot here as it has been for so long. It is summer. So you got to expect it. Yeah, but it is. It's warm. So how y'all going? I need to take the book down to the seashore and try and show off some examples of what we've just learnt about the seaweeds and so on along the rock shores around here. So maybe we've got some snails which really look like nerite snails, and some people have probably told me that they probably are nerite snails, but we still don't know. They're not completely colourful, but some nice like blacks and whites and so forth, colours and shades and so forth to make them an interesting thing. But I don't know if they can be converted to fresh water. That I'd imagine they'd survive brackish, but again, can't confirm. Don't know. They might just be fully salt water, but they will get exposed at low tide, so exposed to the air. So it's interesting critters, that's for sure. Right, I need to refresh my coffee. Sorry, I'll be back in 1 second. Oh, no water. So yeah, what are you up to? You anybody doing anything interesting? Yeah, exactly, Chewy. That's it. So there's a chance that they may be a nerite snail, but yeah, as I said, I don't know if I can convert them this species of, but yeah, still might be interesting to try and find out. They are in their millions. If I take 2, it may not affect the population too much. coffee. So yeah, my camera is for some reason just extremely dark whenever I try to take a video with it these days. So I don't know what's happened there. So that sucks. But in direct sunlight, it seems to operate still. But in the slightest shadow, it just is too dark and you can't see a thing. It's just black. It's crazy. It gives me a shit. So I'll have to take that in and get looked at. I can't work out what's wrong with it. Hopefully it's just a setting, but it'll probably still cost me $100 if even if it's just a setting change and it takes them a minute. Oh well. Yeah, Chewy, I'll go get some and, or at least take the camera down and show you some. And there's numerous different colours, but again, none of them are any of the totally spectacular coloured nerite snails that you see. But yeah, still some pretty cool like zebras and stuff like that sort of colour about them, which are pretty interesting looking snail, that's for sure. And yeah, they got to be tough little critters because when the Southern Indian Ocean comes a calling, she's a tough beast. It's a wild ocean, and they're hanging on the rocks for grim death, getting hammered by waves. That yeah, of all sizes. But hopefully I can get down there in a time when it's not that rough and show you what's going on. The kids are all back to school tomorrow, I do believe, around here, so that's going to make it interesting. Excuse me. Yeah, I hope you're doing all right. Hope you're doing well. Yeah, no idea whether we can hear that. Do you really understand me? To think that you can. Sitting here without you, solitary man. Trying to get through to you. There's no answer again today. The kids and the dogs are fine. You know it's breaking this heart of mine. Still trying to get through to you. Answer again today. Heavy handed there. Sunset Jen, good to see you. Not to do what I have done in your life. Cool. Awesome at Sunset Chen. Hope they're enjoying it. We may have already done this. try. You may slip, you may slide, you may find yourself by the roadside. Don't you let nobody drag your spirit down. If you're on the road to heaven, don't let nobody turn you around. Woo. Not sure if I can do this. Chance. Tell her that I need get a second chance, but for 24 years I've been living next door to Alice. Or a chance to tell her that I need her, maybe get a second glance, and for 24 years I've been living next door to Alice. The truck rolled up into Alice's drive. Me and Alice. Get a second chance, but for 24 years I've been living next door to Alice. 24 years. Where that did I already sing that bit? I don't know the words, sorry. Shame, cool song. It's a bit hot here. A bit hot still. But have coffee. Have coffee, will travel. So for those that were here earlier and saw the fascinating reading of Australian Seashore Life by John Childs. We're now up to chapter 3, I believe, so there's more to come. You haven't missed it all. You're still with a chance. So come on. Do you reckon we do it? We track down how to sing Alice. I reckon that's the go. Living next door to Alice. Come on. Yeehaw. Living next door to Alice. Chord. It's right at the top of the search. So I must have been there before. Maybe some other. Wouldn't be some other drunken evening by chance. Surely not. Oh, different chords. They're different chords, man. Sally called, she got the word. She said, I suppose you've heard about Alice. When I rushed to the window and I looked outside, I could hardly believe my eyes. And the big limousine rolled up into Alice's drive. I don't know why she's leaving, where she's gonna go. I guess she's got her reasons, but I just wanna know. 'Cause for 24 years I've been living next door to Alice. 24 years just waiting for a chance. Tell her how I feel and maybe get a second glance. Now get used to not living next door to Alice. We grew up together, two kids in the park. We carved our initials deep in the bark. Oh, me and Alice. Now she walks to the door with her head held high. Just for a moment, I caught her eye as that limousine pulls out of Alice's drive. I don't know why she's leaving, where she's gonna go. I guess she's got her reasons, but I just don't wanna know. 'Cause for 24 years I've been living next door to Alice. 24 years just waiting for a chance. Tell her how I feel and maybe get a second glance. Now I gotta get used to not living next door to Alice. And Sally called back, asked how I felt. She said, I know how to help. Get over Alice. She said, now Alice is gone, but I'm still here. You know, I've been waiting for 24 years. Then the big limousine disappeared. Well, I don't know why she's leaving, where she's gonna go. I guess she's got her reasons, but I just don't wanna know. 'Cause for 24 years I've been living next door to Alice. 24 years waiting for a chance to tell her how I feel and maybe get a second glance. Now I gotta get used to not living next door to Alice. No, I'll never get used to not living next door to Alice. Oh well, I think we got there. We got there somehow. Ouch. Fingers are a little bit touchy. So let's do a one where I don't have to move my fingers. I can just leave them sit in one spot, make them even more painful. Ouch! Oh well. John Denver song. Thanks, John Denver. Sunshine on my shoulders makes me happy. Sunshine in my eyes can make me cry. Sunshine on the water looks so lovely. Sunshine almost always makes me high. And if I had a day that I could give you, I'd give to you a day just like today. And if I had a song that I could sing for you, I'd sing a song to make you feel this way. Sunshine on my shoulders makes me happy. Sunshine in my eyes can make me cry. Sunshine on the water looks so lovely. Sunshine almost always makes me high. And if I had a tale that I could tell you, I'd tell a tale sure to make you smile. If I had a wish that I could wish for you, I'd make a wish for sunshine all the while. Sunshine on my shoulders makes me happy. Sunshine in my eyes can make me cry. Sunshine on the water looks so lovely. Sunshine almost always makes me high. Sunshine almost all the time makes me high. sunshine almost always. There must be some kind of way out of here, said the joker to the thief. There's too much confusion, can't get no relief. Businessmen, they drink my wine, plowmen dig my earth. None will ever on the line. Body watching his word. Yeah. No reason to get excited. The thief kindly spoke. There are many here among us who feel that life is but a joke. You and I, we've been through that. This is not our fate. So let us not talk falsely now, cause the hour's getting late. Yeah. All the watchtower trenches kept their view. All the women came and went, barefoot servants too. Outside in the cold distance, a wildcat did growl. Riders were approaching, and the wind began to howl. Yeah. Woo! It's getting warm here. It's getting hotter as the night goes on, which is strange. Never like that. Here's a song by an Australian country singer called Tory Forsyth. Song about Johnny Cash, sort of dedicated to Johnny Cash and June Carter Cash. It's called Johnny and June. Well, I could be your Johnny if you'll be my June. We'll have a beautiful, tragic end, a romantic mist that lives on, accelerate and descend. We'll make mistakes and have heartbreaks, live under each other's skin. Oh, when they come for you, forget what we've been through, be ready to begin again. Ooh, yeah. Ooh, yeah. Take the time to let the bullet holes mend and let the wounds change their season. Let it melt away from what it was. Won't let the burns affect my hands. 'Cause when we're high off the feelings, we feed off each other. When I close my eyes, I picture no one else being my lover. Ooh, setting Johnny and June on fire. Ooh, the love that'll lead you blind. Ooh, setting Johnny and June on fire. Ooh, the love that'll leave you blind. Remember how much you said there was a road through my head. It was the object of your desire. So when you promised me, babe, that on my last day you'll hold my hand and you won't cry. Ooh, setting Johnny and June on fire. Ooh, love that'll leave you blind. Oh, setting Johnny and June on fire. Oh, the love that'll leave you blind. Ooh, setting Johnny and June on fire. Oh, the love that'll leave you blind. Oh, man. It's a bit hot. Like, man, it's cooking. So there we go. So that was Tori Forsyth, Australian country singer. Geez, can we make that one work? I don't think we can. I don't think I can make that work, but let's give it a go. Never get scared off. I don't know if I can do that song, but I really don't. Oh, man, it's sore. I really don't think this next song is going to be possible. Holy moly, my fingers are sore. Lying in my bed, I hear the clock tick, and I think of you turning in circles. Confusion is nothing new. Flashback to warm nights almost left behind. Suitcase of memories. Time after sometimes you picture me. I'm walking too far ahead. You're calling to me. I can't hear what you have said. You say, go slow. I fall behind. The second hand unwinds. If you're lost, you can look, you will find me. Time after time. If you fall, I will catch you, I'll be waiting. Time after time. After my picture fades, darkness has turned to gray. Watching through windows, I'm wondering if you're okay. And you say, go slow. I fall behind. The drum. No eye trouble here. The drum beats out of time. If you're lost, you can look, you will find me. Time after time. If you fall, I will catch you, I will be waiting. Time after time. 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 Didn't think we'd get through that one. That was amazing. Anyone who ever had a heart wouldn't turn around and break it. Everyone who ever played a part wouldn't turn around and hate it. sweet Jane. Sweet Jane. Oh, sweet Jane. You wait for Jimmy down in the alley, waiting there for him to come back home. Waiting down on the corner, thinking of ways to get back home. Sweet Jane. Sweet Jane. Oh, sweet, sweet Jane. Anyone who have had a dream, anyone who'd ever played a part, anyone who's ever been lonely, anyone who's split apart. Well, sweet Jane. Oh, sweet, sweet Jane. Oh, sweet Jane. Heavenly wine and roses, she no wish to me when you smile. Heavenly wine and roses, she no wish to me when you smile. La 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 la. La 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 la. La 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 la. Sweet Jane. Sweet, sweet Jane. Oh, sweet, sweet Jane. Sweet Jane. Well, it's 2 a.m. Feeling's gone. The fear is gone, not the feeling. A song by Golden Earring called The Twilight Zone. Well, it's 2 a.m. Fear is gone. When I'm sitting here waiting, the gun's still warm. Maybe my connection is tired of taking chances. Yeah, there's a storm on the loose. Sirens in my head, wrapped in silence, all the circuits are dead. Cannot decode, my whole life spins into a frenzy. Help me, I'm stepping into the Twilight Zone. The place is a madhouse, feels like being cloned. My beacon's been moved under the moon and stars. Where am I to go now that I've gone too far? Well, you will come to know when the bullet hits the bone. And you will come to know when the bullet hits the bone. Well, I'm falling down a spiral, destination unknown. Double-crossed messenger all alone. Can't get no connection. Can't get through, where are you? Well, the night night weighs heavy on his guilty mind. This far from the borderline, the hitman comes. He knows damn well that he's been cheated, and he says, "Help me, I'm stepping into the Twilight Zone. The place is a madhouse, feels like being cloned. My bacon's been moved under the moon and stars. Where am I to go now that I've gone too far? You'll come to know when the bullet hits the bone. You will come to know when the bullet hits the bone. Come to know when the bullet hits the bone." Cheers, Sunset Jen and housemate. Hope you're going all right. Yeah, right. 1:30. Far out. It is 10:30 here. I should become quiet, I believe. But thanks for hanging out. It was awesome. Man, I can't believe how hot it is. And getting hotter. Insane heat. Tell you what, I don't know how rock and roll bands do it on stage during like these daytime festivals. It might be 40 degrees and they're live on stage, jumping all over the place. Insane. Okay, so thanks everyone for being here. Call it quits. As I said, it's 10:40 p.m. here. So maybe somebody else is about to start. I don't know. Who knows? I'll have a look. I've already been going much longer than I intended. It's been cool. See, Degenerate started 40 minutes ago. So that's me gone. All right. Thanks, everyone. Take care. See you next time. Thanks for hanging out. Head across to Degenerate Fish Keeper. Degenerate Fish Keeper is